Hello everyone, welcome back to Math with Allison. Today we're continuing our series on derivatives, and actually we're continuing the topic on related rates. So today we're going to do a bit more complicated problems where there's multiple moving parts. So let's go ahead and dive into it, and of course we're going to start off with an example because I love throwing you guys into the lava. So let's read the example. Sand falls from an overhead bin, accumulating in a conical pile with a radius that is always 3 times its height. If the sand falls from the bin at a rate of 120 feet cubed per minute, how fast is the height of the sand pile changing when the pile is 10 feet high? So first we are going to write out the given information, so what's important. So first we have that the radius is always 3 times its height. So if I write that out with an equation, I get radius is equal to 3 times height. Next, we have that the sand falls into the bin at a rate of 120 feet cubed per minute. So actually the notation feet cubed per minute is going to give you a hint. This is going to be the rate of change of the volume. So when I write that out, it's going to be the derivative in terms of time of the volume, or volume prime, however you like to write it, and that's going to be equal to 120. And so what we are wanting to find is how fast the pile of the sand is changing. And so what that means is we want to find that the derivative d dt of h, or h prime, and this is what we want to find. We have one more small piece of information here, and that is when the pile is already 10 feet high. And so we get a value h is equal to 10. So let's go ahead and draw a picture. I'm going to go ahead and draw a cone. So here's my beautiful drawing of a cone. Let's go ahead and label the parts. So first we have that this is going to be equal to the height. And then we also want to include the radius in there. So this is going to be the radius, right? Let's go ahead and write out the equations that we need. First, we have the one that we're given, which is that the radius is equal to 3 times the height. And now we also need the equation of volume, equal to 1/3 pi r squared times 8. So what we need to do here is we need to substitute what our radius is equal to. We're going to combine these two equations into one. So I get 3h quantity squared times h. When we multiply that out, I get 1/3 pi, and then 3h quantity squared is equal to 9h, and then times 8. 9h squared times h. So let's go ahead and simplify that one more time. So I know that 9 divides 3, and I'm left with a 3 right here. And we can also combine those h's. So I get 3 pi h cubed. So now what we want to go ahead and do is differentiate this equation. I'm going to take the derivative of both sides in terms of t. So I know the derivative of v is just going to be v prime, right? And now let's go ahead and take the derivative of the other side. These two right here are scalars, so I don't need to worry about them. What I am going to take the derivative of is this h cubed. And I'm not going to write it out with chain rule this time. I'm just going to say it explicitly. So like we said, that 3 pi hangs around. And now I'm going to use chain rule. So the derivative of the outside is going to be exponent rule. So I bring that 3 down and I subtract 1 from the exponent. But now we need to multiply by the derivative of the inside. So the derivative of just h is going to be h prime. If we combine some things to make this look a bit prettier, I can multiply that 3 times 3 and I get 9 pi h squared times h prime. So now what we're going to do is fill in what we know. And if we remember, I'll zoom out right here. V prime was equal to 120. So I get 120 equals 9 pi. H squared was equal to 10. And then that h prime is what we want to solve for. I wrote that out terribly, but you get the idea. Let's go ahead and multiply this out. So I get 9 times 10 is 90 pi times h prime. I'll just divide both sides by 90 pi. So I get 120 divided by 90 pi is equal to h. And if we wanted, we could simplify this a little bit. So if I take 30 out of both the numerator and the denominator, I'm left with a 4 and a 3. So here I get 4 over 3 pi equals h prime, sorry. And this, in terms of our measurements, we can go back to the original question to find that. So here we're working with feet and we're working with minutes. So this is going to be feet per minute. So now our last step that we want to do is write out our solution very nicely. And so let me go ahead and do that. And there we have it. That's our solution. So let's move on here to the next problem. The radius of an adjustable right circular cylindrical tank If you're wondering what that is, there's a picture right there. It's just a cylinder. Is increasing at a rate of 3 centimeters per hour, but its surface area remains constant at 9 centimeters squared. When the radius is 2 centimeters, at what rate is the height changing, and is it increasing or decreasing? We're given a hint right here. We have the surface area equation is equal to 2 pi r squared plus 2 pi r h. So we already have this beautiful picture right here. Let's go ahead and fill it in with some things. And so I know this right here is going to be equal to the height. And then from here to about here, that's going to be the radius, right? So those are the only moving parts we have going on here. And let's go ahead and fill in information that we know. So we know that the radius is increasing at a rate of 3 centimeters per hour. So the derivative of r, or r prime, is equal to 3. Next, we have that the surface area remains constant at 9 centimeters cubed. So the surface area is equal to 9. This also tells us something about the derivative. So that means that the derivative d dt of a, or a prime, when it remains constant, the rate is unchanging, aka it's 0. It doesn't change, it's not increasing, it's not decreasing, it's just remaining exactly the same, so the rate of change is 0. So that's actually going to be very useful in the next steps. So what else do we have? We have that the radius is equal to 2 centimeters. And we want to find out what rate is the height changing and if it's increasing or decreasing. Okay, so let's go ahead and take our equation. We are missing one piece of information. If you know what it is, that's super awesome. I'm going to start by taking the derivative and see what I'm missing, because sometimes that's very helpful to help see the bigger picture. So let's go ahead and differentiate. So the derivative of a is just going to be a prime, right? And I'm going to go ahead and simplify this right side up a little bit. So remember that scalars just hang out. They don't make a difference at all. And we're just taking the derivative of the variables. So I'm going to write this as 2 pi times the derivative of r squared, and then plus 2 pi times the derivative of r times h. If we notice right here, we're going to use chain rule, right? R squared, r is going to be the inside. But then on this other side, we're going to actually have to use product rule. So first, let me go ahead and set up product rule. So when we find the derivatives, we can just leave that as r prime, the first derivative of r, and then h prime, the first derivative of h. And with product rule, all we have to do is multiply them across and add them together. So I'm going to go ahead and write this out. So when we take the derivative of r squared, remember that we take the derivative of the outside. So I use exponent rule, I bring that down, and now I need to multiply by the derivative of the inside, r, which is r prime. And now we can go ahead and fill in product rule. Okay, so now with the given information, let's go ahead and fill in what we're given. So a prime, remember we said that that is equal to 0. So that's very nice. That goes to 0. So we get 2 pi times 2r. And r we said was equal to 2. And then r prime was equal to 3. And now we add 2 pi, and now we need to fill in what we know here. R prime was equal to 3. Oh, interesting. H we are not given. So I'm going to leave that as h. And now I get radius of 2 times h prime, and that is what we wanted to find. So notice right here, we don't know what h is. We need to find h, and we're going to do that with the moment of interest. So what is our moment of interest? That's where we get to use the area of the surface area of our cylinder right here. Because here we're given that the radius was equal to 2, and that the surface area was equal to 9. We want to find what h is equal to, and we can use that with the equation. So when we fill all of that in, I get 9 is equal to 2 pi 2 squared plus 2 pi times 2 times h. So let's go ahead and do some math real quick. Alrighty, we found what h is equal to. I'm not going to simplify that 9 divided by 4 pi because no thank you. So let's go ahead and fill in what that value of h is equal to. Alrighty, we got a nice big equation here. Let's go ahead and start doing some math. So I get 0 is equal to, and let's start right here. So 2 times 2 is 4, times 2 is 8, and then times 3 is 24. So here I get 24 pi. Okay, and then I get plus 2 pi, and let's go ahead and multiply some of this inside. If I distribute the 3 through, I get 27 over 4 pi, and then minus 6, so 2h prime. Distributing this 2 pi all the way through, I get 27 over, and actually that simplifies just a little bit, so those pi's cancel, and then that 2 divides 4, and so that becomes a 2 in the denominator, and then minus 12 pi, and then plus 4 pi h prime. Okay, so we can combine some things here. First, we can combine this 24 pi minus 12 pi. So I get 0 equals, and that is equal to 12 pi plus 27 over 2 plus 4 pi h prime. So let's go ahead and subtract those two terms over. And so here I get negative 12 pi minus 27 over 2 is equal to 4 pi h prime. And remember, we are trying to isolate this h prime all by itself, so I'm going to divide everything by 4 pi. And if we wanted, we could simplify that a little bit, and I get negative 3 minus 13.5 divided by 4 pi. Woo, we got a value. I'm going to leave it at that. I'm not going to simplify very much more. And so now what we want to do is we want to write this out kind of nicely. So we have already, notice here I put that the height is decreasing, and that's because I got a negative value. Negative 3 minus that whole thing is for sure going to be negative. So that's how I know if it's decreasing or increasing. If it was positive, it'd be increasing, right? Okay, we have one more. Let me zoom in a bit. At what rate is soda being sucked out of a cylindrical glass that is 6 inches tall and has a radius of 2 inches? The depth of the soda decreases at a constant rate of 0.25 inches per second. So let's go ahead and fill in important information. So we want to find out what rate the soda is being sucked out of cylindrical glass. And so that means I want to find the rate of change, or the derivative in terms of time, of the volume. Or we can write that as v prime, and that's going to be something. That's what we're finding. So the glass is 6 inches tall and has a radius of 2 inches. Okay, we also have that the depth of the soda decreases at a constant rate of 0.25 inches per second. And so this actually tells us that the derivative of the height of the soda is the thing that's changing. And so we can write that as h prime. And since this is decreasing, this is going to be negative 0.25. So let's go ahead and write out our equation. Okay, so we have the volume of a cylinder, or a cylinder, is equal to pi r squared h. So let's go ahead and take the derivative of this. So I want to take the derivative in terms of time. So first, the derivative of v, or volume, is just going to be v prime. And remember that scalars just hang out. So this scalar of pi is just going to hang out, and we want to take the derivative of r squared times h. And so here what we're actually going to use is product rule. So let's go ahead and set that up. So let's go ahead and fill in these derivatives. The derivative of r squared is going to be 2r times r prime, because we need to multiply by the derivative of the inside. The inside is r. The derivative of h is just going to be h prime. So when we do product rule, we just cross multiply and add those together. So when I do that, that pi hangs out, and now I need to multiply pi by the whole product rule. So here I get 2r r prime times h plus r squared times h prime. So let's go ahead and fill in what we know from our given equation. So this is why I included this problem, because what's r prime? We're sucking it out of a glass that does not have a changing radius. So that actually tells us that r prime is going to be equal to 0. The radius of a glass doesn't change. And so that means this entire term goes to 0, which is super, super nice. So here we get v prime is equal to pi, and now all we have to multiply is 4 times negative 0.25, which that is actually equal to negative 1. And so we get the derivative of volume is equal to negative pi. Let's go ahead and write that out all nicely. And there we have it. So that's all I had for us today. If you enjoyed this video, I have many more like it, so make sure to check out my playlist. They're linked down below. Otherwise, please give this video a thumbs up and comment other topics or problems you'd like to see done. Thanks for watching.